In this example, we're going to look at a block and tackle system. Back in the days before we had hydraulics, block and tackle systems were one of the exclusive ways to have mechanical advantage, to be able to lift and move extremely heavy loads that an individual or even a group of individuals would find very difficult to do. Right? So we've got a 1,000-pound weight here sitting down there, and what force is necessary in this system to lift that 1,000-pound force. Now, assumptions are going to be no slippage of rope, and no friction in the pulley itself. And we'll talk about whether these ropes are not vertical, what that might happen here. Now, this is a little bit different than the previous example where we had a lot of pulleys and that sort of thing. Sorry, let me adjust the focus there. All right, I think we're better on the focus. All right, and so as we're looking at this here, what we want to do is recognize, as always, well, how many pulleys do we have? 1, 2, 3, 4. This one at the top we learned before really doesn't do anything except for redirect the cable force. But we also want to know how many cables we've got. Well, we got one that wraps around here, and then it wraps here, and then it wraps here, and goes. We only have one cable. That's a lot different than the previous example. All right, so what we're going to do is we're going to cut through in our free body diagram here and here, and instead of isolating a single pulley, we're going to instead cut off a sub-part of that pulley system. And so let's get our circle template out again, and let's set this thing up. This is going to be, of course, our free body diagram. That's our first step of the lower pulleys. We have ultimately here 1,000 pounds that are being loaded onto the system. And then we want to reasonably show the pulley cables that are in here. So we've got a cable here. Now we're going to assume that it's vertical. Little segment there. Then we got a segment coming up here. We've got one that wraps around this pulley. Wow, this gets kind of confusing, right? We've got, let's take this little inner one. There's a little inner one. And then we got this one that wraps around here. Alright, so that's all of the ones that are cut and exposed. Now, notice I'm showing them all as though they were perfectly vertical. Right now, it's the same pulley and no slippage and no frictional kinds of things going on here. So, hey, our couple of things. One, all of these have to be the same value because it's the same cable, and we're ignoring friction out of it here. So no rope slippage, no friction. See how much different this is than what we did before. Now you're like, well, what connects these things together? Remember, there's a bracket that connects these two lower pulleys together. So we haven't cut that bracket. That's this little piece right there. Right? So, wow, well, this becomes almost a trivial equation of equilibrium to deal with. It'll take a lot longer for me to write it than to actually just solve it. That we've got then sum of forces in the y, take upwards positive. We have 5t minus 1,000 pounds is equal to 0, so therefore, the math is easy on this one, t is equal to 200 pounds. And there's your answer for that first part. Now, you say, well, what about that part? What are the implications if friction are present? Well, that's going to make each of these a little bit different and makes that analysis more complex. And if the ropes are not all vertical, well, hey, if the vertical aspect of this has to be the same, but you flare them out, flare one of these out to the side, we now have to know its angle, and then we've got to be able to find its vertical component. Once we find the vertical component, then we've got to swing it back along its line of action. It'll only get bigger as a result. So the consequence of not vertical is this is going to go up. Wow, that's going to go up. The other thing is if all these other ones are vertical, but this last one is not. As soon as we start lifting, this thing's going to swing over, right? Because this last one will be off to the side. It'll have an X component. It'll accelerate and move over until it reaches. Then this one will pick up probably a horizontal component, and now you have to have equilibrium in the X direction before, and that thing will settle down. But it'll increase the cable force.